All right. Welcome, everybody. It's a delight to welcome you to our last SODA symposium in this semester. The topic for today is gathering and sampling social media streams, something that many of you around the University of Maryland campus, but also many of the social scientists outside of campus do think about, worry about, try out new things. And so it's pretty exciting for me to see the large interest in the seminar. And I'm very glad that we have two wonderful speakers to share their work and enough time at the end for a Q&A with them. If you want to post questions while they are talking so that we can field them in the Q&A at the end, you see at the bottom of your screen the little Q&A box. And frankly, after a year in the pandemic, you probably all have done this multiple times, but just to make sure. I will call up both panelists on the podium at the end, and then I will field your questions to them. So I'm going to introduce the panelists, and if you want to turn on your video screens, make sure everyone can see you. And our first speaker will be Trent Busker. He is the Nowak Family Professor of Data Science and Chair of Applied Statistics and Operation at Bowling Green State University. Trent and I know each other for many years through APOR, the American Association of Public Opinion Research. You see a little sock in the background. That's from the recent conference, Devotionalia. But more importantly, Trent's research involves applications of machine learning and data science, a methodology to design, evaluate, and analyze data from all fields: health, social science, survey research. He works on design and development of new methodologies and data collection, including Paradata, to evaluate the quality of the data collection. And he most recently investigates methods for improving inferences that can be derived from big data, social media, and other forms of non-probability-based data. Our second speaker is Edward Summers. He's research faculty member at the Maryland Institute for Technologies in the Humanities here at the University of Maryland. Ed is a software developer, teacher, and researcher working on the intersection of libraries, archives, and the World Wide Web. So, perfect combo here. In his research, he studies how the web functions as a socio-technical system, especially with regard to memory practices such as curation and preservation. So, for all of us who like to sample and archive those tweets, pretty relevant talks. So without further ado, I'll ask you, Trent, to take over, and I'll turn off my mic and camera, and the floor is yours.
Thank you, Frauke. Let me share my screen here. Okay, hopefully everybody can see. Again, thank you so much for inviting me. I'm really happy to be here to talk a little bit about some work that we've been doing since the COVID pandemic started. This work would not have been possible without the help of my BGSU COVID team. So the members, I want to just thank our Brian, Ravi, Yuji, Herb, and Adam. Really, really helpful team doing tons of work in this area. I just want to start with saying that it might be time for Twitter. Did you know that people used to write notes on paper and secretly pass them around in class? What? When did that supposedly happen? I don't know, but it must have been BT. BT before Twitter. Since you're all muted, I'm just going to assume and impute laughter in my own microphone, or headset, so let's keep going. As you all may know, Twitter and social media use is on the rise. Pew estimates that about 70% of US adults use some sort of social media, and not all users use at the same rate, obviously. A 2017 survey of 300 medium to large businesses conducted by digital marketing at Clutch found that about 79% use Twitter for social listening activities, 25% use social listening to improve products, and about 21% use social listening to improve customer experience. The use of Twitter goes well beyond business sector. It goes into the social sciences and so on, where we're trying to see more and more inferences coming or drawn from Twitter, or things that we can learn from Twitter, or use Twitter as potentially a qualitative assessment of our focus groups or our questions, etc. But despite all of that sort of activity, there has been a little bit less work really focused on how to create samples from Twitter that describe that have desirable properties of representation and replication. Hino and Fahey in 2019 did something like this where they actually created an archive of Twitter data that represented the user population. And the difficulty here is that Twitter actually has limits on the number of public tweets that are available for folks. And so if you're trying to sample with respect to the number of tweets that a potential user has available on Twitter, all those sampling weights are capped at the 3,200 limit at one time. Berzofsky and others in 2018 applied a similar approach, taking a systematic sample of Twitter user IDs, again, focusing on the user, and built a sampling frame to gather tweets from those users. In our work, we've taken a very different view of the Twitter space. We actually are going to focus on sampling tweets rather than users from a particular day and geographic region. So in our preliminary work, we discovered from the work of Pfeffer and colleagues in 2018, a connection between the time of day and the tweet ID. In fact, the first 42 bits of a 64-bit tweet ID contain a timestamp of when the tweet happened. So by using that information, we can create synthetic tweet IDs to use as placeholders for time-based samples of tweets. So that's really what we're going to focus on in our talk today. Our goal is to create a sample of tweets that reflects the volume of total tweets over a given day from a given region. We're doing this because people may want to study Twitter locally, or they may want to study it globally. And so this gives you the flexibility to hone in on a region and a time element. It doesn't have to be a day, it can be longer than that, but we are thinking about Twitter volumes and being able to represent these things accordingly. So our focus has been on, or was on, the day and region. And we, again, created these synthetic tweet IDs that were based on times that we wanted to sample from. And then we were able to use the Twitter APIs to pass this through. I think Ed is going to talk a little bit about the Twitter API version 2.0, which has a time-based element in it, but the Twitter API version 1.0, upon which this work is based, does not have that element in it. So we have to create a way to select time as opposed to tweet IDs or user IDs. The Twitter, so essentially we're going to incorporate time into the method. The Twitter volumes are converted to corresponding time intervals. So the idea here is that we would be looking at the Twitter volumes, and lower volumes in the day would be wider time intervals, and higher volumes would be narrower time intervals. And the idea is to get to cluster time intervals with respect to about the expected number of tweets, about the same number of expected number of tweets in each of these intervals, for the idea that when you query Twitter with an API, there's a limited number of tweets that you can get returned from a given query. We set that limit to be 100, which was the maximum for the version 1.0. It can be set to higher with the version 2.0, which I'm sure Ed will discuss a little bit later. We'll then sample these time intervals that we call tweet PSUs. Again, these time intervals are created such that the expected number of tweets that occur in those intervals is approximately 100. This creates efficiency in our gathering algorithms so that we can maximize the yield that we get from the Twitter API. We're calling this algorithm velocity-based estimates for sampling tweets, or otherwise shortened to be VBEST. So the algorithm occurs in several steps. The first step is that we select an initial set of tweets from uniform time points across the day. We use about 48 of these time points randomly, uniformly spaced from across the day. And we pull 2 queries, each of 100 tweets, each at each of these selected time points by using the conversion of the time point to the tweet ID. And we We use the Twitter Search API for this. And then the second step, we actually use the returned tweets to estimate the velocity by which the tweets are coming in at a given time point. So we have timestamps on all the tweets coming in. We know how long it takes us to get these 100 or 200 tweets. We take that information and we calculate a velocity of tweets per second in that time interval. Using these tweets per second, we then estimate a velocity, a Twitter velocity curve using a locally estimated scatter plot smoothing, or LOS, with a polynomial regression fitting machine learning algorithm. This gives us an overall velocity-based curve estimate for the number of tweets, or the velocity of tweets per day. The area under this curve is mathematically equivalent to the number of tweets that are represented in a given day and a region. So we use the area under that curve to come up with these time intervals that have expected number of tweets to be 100 each. So this is the idea. I will skip this here for the visual, but essentially Twitter starts at the end of the day and works its way backwards. So this is how you're going to see us talk about this. And then when we select a time point, we gather tweets in that time point. We have a first timestamp. We have the last timestamp from the last tweet. We know how many tweets we've gathered. We can calculate a velocity. We use that velocity as input into our next step, which is to create the overall curves, the overall Twitter velocity curve. Then we create a sampling frame of primary sampling units called tweet PSUs. And we estimate the area under this velocity curve using a 3-point trapezoidal rule over 86,401 second time point intervals. And then we actually get these PSU boundaries that are essentially time points that correspond to times of the day where we expect to get about 100 tweets per tweet PSU. Then we take the VBEST sample. The VBEST sample is approximately a 25 to 50% systematic sample, at least that's what we've tested, of tweet PSUs taken throughout the day in a given region. The upper endpoint, the rightmost endpoint of each selected tweet PSU, is then the timestamp that we use for querying Twitter to gather those tweets that we would expect from Twitter itself using the Twitter Search API. And the collection of resulting tweets from processing all of the queries throughout the day is going to be our VBEST Twitter sample. We also have a variant of this where we're taking a simple random sample of these tweet PSUs as opposed to a systematic sample, and we're going to compare them. So using this algorithm, we've actually, and just to give you an idea, this is the Twitter velocity curve that I mentioned. We integrate this curve and we come up with a Twitter PSU that essentially is an interval that has an expected number of tweets to be 100 using our projected Twitter velocity curve that we used, or we estimated using those Twitter velocities in the beginning. So this is just an illustration of how accurate this LOS curve is. Here are the 48 time points in Atlanta on November 5th, 2020. We've estimated the velocities here. This is our LOS curve that sort of fit to these velocities. And then underlying this, these green bars is the actual volume of tweets that came in when we did a census on that particular day. And you can very clearly see that the LOS curve estimates the Twitter volume very, very closely. We've done this repeatedly over a pre-experiment, and we've been able to estimate that our error in getting this Twitter distribution correct is about 2 to 5 percentage points overall consistently over about a 90-day period. So we think that this tool is actually, it shows a lot of promise. So we wanted to test it in an experiment. So what we did was we actually used 6 different methods for sampling. The first three, popular, mixed, and recent, are the Twitter default methods that you would get if you tried to log into Twitter and used it yourself. You could pick one of these 3 methods for gathering tweets. Uniform and SRS with the VBEST sampling frame and the VBEST samples are the new things that we're trying to test here. Uniform is just simply selecting time points that are uniformly spaced throughout the day and then querying those time points to gather the tweets. We also tested sample sizes of 720 tweets, 540 queries, and 360 queries. And for the last 2 methods, we had to subtract 96 from that number to use as the overhead for our low S curve estimation to build the sampling frame. So those queries are going to be 444 and 264 and 624 respectively for the number of queries that we would pull to generate our samples. So from there, this is just sort of the depiction of these things. So when you gather the recent tweets, samples are going to look like this, where it's shaded in. This is where the samples are going to be generated. Uniform is going to be throughout the day. Simple random sample VBEST is going to be selecting these tweet PSUs all throughout the day. And then the VBEST algorithm is doing this systematically. So I'm getting sort of more uniform coverage from the full spectrum of the day. Our field period ran for 38 days from just before Thanksgiving to the end of December. And we are looking at 5 different metropolitan statistical regions here. We did not include Columbus in this one because we had some technical glitches from our vendor. So we won't be talking about Columbus. And then in order to gather these tweets, we had to specify a geocenter, a geolocation coordinates for the center of the metropolitan statistical area. And we selected a radius that would be the smallest possible radius to encompass all the principal cities that make up the MSA. So these radii are different for the different MSAs because they have different geographic topologies. So we're using those accordingly. And so the idea is that when Twitter draws this using the search API, you have to specify a coordinate and a circle. And then we're going to do some geo-filtering based on the user location of the, or based on the location that is recorded in the user metadata for the tweet in order to figure out if that tweet is going to be retained for our analysis or not. We did this because our vendor through the Firehose was able to get city-based tweets, and we were not able to get city-based tweets. So we needed this geo filtering step in order to do that. We also are looking for a couple of outcomes that we care about are topics related to COVID. So we have a bunch of these. We have 8 keyword groups, and then we have the keywords here. So what we were looking for is keyword-based frequencies and keyword group-based incidences for these particular groups. This was a COVID-related project, and so we were looking at COVID-related outcomes. And so essentially, the working keyword group estimate is going to come from whether or not a tweet has any one of these keywords in it. So we don't really care about the individual keywords, we're really caring about these categories. So does a tweet talk about working as defined by these keywords? Does it talk about COVID as defined by these keywords? So what we're going to do to evaluate this is the percent relative absolute bias. So we have an estimate from our Twitter samples. We're going to compare that estimate to what we get from the Firehose from an independent vendor. And we're going to take that relatively speaking to the estimate from the Firehose. We're also going to average across these 8 keyword categories just to give you an overall picture of how well the sample is performing. So we gathered our sample tweets, and I have a little bit of time to tell you these results. In total, we have over 112 million tweets that we've gathered from these metropolitan statistical areas. We filtered them into the principal cities. That left us with about 80 million tweets. And then we filtered by keywords to look at these analyses, and that left us with about 2 million tweets that actually fell into one of the keyword categories that we mentioned. And again, the MSAs that we're considering here are Atlanta, Baltimore, Chicago, Phoenix, and Pittsburgh. So the first result that we looked at was just whether or not we can get an estimate of the tweet universe. How big was the Twitter population for a given MSA by method and sample size? And so one of the things that jumps out, so what we're estimating here is the Twitter population, the number of tweets that appear in Atlanta MSA from our samples relative to what we got from the vendor. So this was after we had to geo-filter the samples. What you see very quickly is that the mixed method and the popular method, which are defaults in Twitter. In fact, if you don't do anything for the Twitter search API, the mixed method is the default. Those 2 methods are horrible on their sample performance relative to the bias. So when we look at the recent method, the uniform, the SRS, and the VBEST, these methods typically are better, but the SRS and the VBEST methods, at least for estimating the tweet population or the total size of tweets, is better than uniform and recent. In fact, recent is overestimating that amount and uniform is underestimating that amount, keeping apprised that this is the absolute bias, but the direction of that bias is actually different depending on the method that you use. This just shows you a little bit of the breakdown in the method and sample size and region graph. We do notice that some of the regions behave slightly differently, but the curve is generally the same. Recent is not as good as SRS or VBEST, and uniform is uniformly bad across these groups for estimating the size, and we'll talk about why that is in just a second. And of course, if you look at Chicago is the largest area and Baltimore and Pittsburgh are the smallest areas. And one thing that you notice that is as the sample size increases, recent gets better for generating these estimates of Twitter volume. So I'll tell you why that is in just a second. So now we looked again at the overall percent relative absolute bias for keyword category frequency. So I cared about the number of terms that were related to COVID, or the number of tweets that had a term that was related to masks, etc. And I averaged across these 8 keyword categories to get an overall mean percent relative absolute bias. And again, the picture is similar. That you see that in some of these cases, recent is good for larger sample sizes in the smaller cities or metropolitan statistical areas, but in the larger ones like Chicago, Atlanta, recent isn't as good as SRS or VBEST, no matter what the sample size is. And uniform across all of these is actually doing a poorer job at estimating totals, frequencies, if you will, from these samples. And again, if I just focus on the recent uniform SRS and VBEST, you're starting to see a little bit of that here. Obviously, there is a sample size effect. The more queries that I do, the better the performance, but it is not, it has some negligible returns for simple random sampling and VBEST compared to, say, recent, and I'll tell you why that is in just a minute. Here is an example from the Baltimore area. This is one of our smaller MSAs. And if you notice that this line with the green background, so the blue line is representative of the Twitter volume throughout the day. And this is actually from a full corpus of Twitter that we were actually able to gather on a few selected days. At 320 queries, it takes us to about 44% of the volume. At 720 queries, we get to about 88% of the volume. So when we're projecting keyword frequencies using a recent method with a large number of queries, we're effectively covering almost the entire corpus of Twitter. So we're actually getting a reasonable estimate of what's happening by virtue of almost a census. So this is why you get some interaction between the method and the location or the region and the sample size because of the distribution of the underlying Twitter, the Twitter space in terms of when the tweets come in. And so if we turn our attention to Chicago, which is a much larger area in terms of Twitter volume, you can see that after 720 queries, we're only covering about 22% of all of the tweets in a given day. And we're making projections based on those from our recent samples to the rest of the day, which turns out to be not such a great idea. The uniform, on the other hand, is actually oversampling this area in what we call the trough region, which is giving us too small of Twitter volume estimates. And we're combining that with larger Twitter volume estimates to get an overall underestimate of what's happening. So this is why the uniform methodology or the uniform samples aren't working as well either. We also looked at collecting this. Obviously, we did this over several days. And so this is just a really rough picture of the accuracy of the relative absolute biases by method across the days. One thing that you notice here is that the method that has the most spikes, in other words, it's the method that has perturbations that you can actually see with the naked eye, is the recent method. It is the one where it's the most sensitive to Twitter volume distribution changes from day to day to day. So this is actually one of the default methods in Twitter, and we do see some variability in this method with respect to the precision values that we're getting across our field period. And finally, if we look at the percent relative absolute bias by region, method, and size for incidence rates, we can see that the methods are a little bit more comparable in terms of overall estimate of keyword incidence. They don't do as well for frequency. So this is what I have to talk about. I'll just give you a couple of takeaways and then I'll turn it back over to Frauke. We analyzed two main outcomes, the Twitter population and then this frequency of tweets. And generally we had some mixed results, but we did see that the SRS and VBEST methods tend to be more stable and better estimates for frequency-based estimation. And the uniform and recent are a little bit they're a little bit more dicey in terms of their accuracy or their consistency. We are doing an experiment to figure out ways to tweak our initial velocity curve estimates to make that better. And that's sort of future work that we're exploring now. So thanks a lot for listening. Hope you enjoyed the talk.
Great, thank you, Trent. This was wonderful, and I'm going to use this opportunity to tell people here that are listening to this that Trent and I just got a recent grant awarded, and we will be using this methodology to draw samples from Twitter, and it's all related to privacy. So if any one of you in the audience is looking for a job, please do apply. We have a job posting out there at SOTA. And so, this can be the beginning for everyone else, but also those. Please do post your questions to Trent in the Q&A session, and feel free to turn on your video and start sharing your slides. You're up next. I think you're unmuted. Yes, thanks. Great.
So hopefully you can see my screen okay.
Yes, we can. Thank you.
Great. Yeah, thank you for the invitation to take part in this event today. It was mentioned in my intro, but I work at the Maryland Institute for Technology and the Humanities, which is a center at the University of Maryland. And I also work as an instructor in the College of Information Studies at University of Maryland. And in both roles, I sort of work as a software developer and also a data practitioner. So I sort of help faculty and students with research that largely involves, studying the web and studying the web as socio-technical systems. So the different platforms that exist on the web, very often people are interested in studying them. And Twitter happens to be one that I focused a considerable amount of time on. Largely this project called Documenting the Now, which I may mention near the end of the talk if there's time. So the talk, I gave it this title, Notes from the API Calypse, the Twitter version 2 API. And as Trent mentioned, I am going to be talking about the version 2 API primarily, but we're going to kind of zoom out a little bit to talk about the Twitter platform as a whole. This picture here on the left is the 4 horsemen of the apocalypse. API Calypse is a play on words that I'm going to talk about in a second. And it's not something that I came up with. But yeah, the basic idea is that this is a reference to the apocalypse. So, this is zooming out quite a bit, but so when we talk about studying social media platforms like Twitter, I think that, it's important to understand how it's being studied, right? And so when you use social media data like Twitter data, it's important to know how it's been sampled, as we just heard about, right? And so I mentioned this at the beginning because it's important for me in my own work that that Twitter is not necessarily used as a proxy for the population as a whole. This is just a graphic from a study that Pew Research Center did in 2019, where they surveyed active users of Twitter and compared them in a very kind of simple way to sort of demographic characteristics of the United States as a whole. And you can see, in blue, the percentages of for Twitter users, and then in white, those little circles are for the population as a whole. And you can see that, Twitter users skew to the younger demographic. They tend to be more educated. They tend to make more money. And these things are important, right? When you look at Twitter data, especially if you're looking at it as a proxy for a population. But that being said, and this is really where my research focuses more, is Twitter is a platform where things happen, right? And so even when you're not looking at it as a proxy for the population, there are all sorts of things that are happening on Twitter that are important to study and to understand. And so that, I'm thinking here of, like disinformation campaigns, in politics, right? There's hate speech and spam and various kinds of abuse that happen on Twitter that are really important to study, trolling. So those are all negative things. But on the positive side, Twitter is used as a platform for activism. I'm thinking here of like the Black Lives Matter movement or the Me Too hashtags, right? These were significant events that transpired on this platform that are important to study for cultural and political reasons, right? So, so that's just a little bit about studying Twitter as a platform. Now, this is a kind of a lovely book that came out, I think, last year from Jean Burgess and Nancy Bayham, entitled Twitter, a Biography. And the book is 280 pages, just like, there are 280 characters in a tweet. But it basically chronicles the history of Twitter, but looking at Twitter through its affordances, so the types of features that it's acquired and how it's acquired them over its lifetime. And one of the things they do early on in the book is sort of just to try to position like why it's important to study Twitter. They did a very simple, Google Scholar search for Twitter in the title of any paper, and they found 61,300 papers. And I just repeated this a couple days ago, and I found 108,000 papers. And so, the reason why they did this was because they were trying to point out that this is a very significant platform to study, and for us as scholars, right? And just to put that in perspective, I also did a very similar search for Facebook, and that found 103,000 papers, which is slightly less than Twitter, right? About the same. But the really weird thing about that, at least from my perspective, is that Facebook has order of magnitude more users than Twitter does. So, Facebook has 2.8 billion active monthly users, and Twitter has 330 million. That's an estimate that I just looked up. But so you'd think that, given the significance and the usage of Facebook as a platform, that it would be used a lot more in titles in Google Scholar, but it's not. And one of the reasons for that, at least that I'm sort of positing here, and I think is fairly, I don't know, maybe we could have a debate about it, but I think one of the significant reasons for that is this application programming interface, or API. And so all these social media platforms make data available to users, to third parties, even internally, sometimes within the corporations, using these things called APIs. And that's the API calypse that I'm going to be talking about here today. APIs, we could spend a long time talking about this, but I like to summarize APIs when I'm trying to describe them quickly as URLs for data. So just like how you have URLs for web pages, like, for example, University of Maryland has a URL, http://umd.edu, right? And when you point your browser at that location, you get some HTML, you get bunch of images and CSS and different things, right? That your browser then renders as a page. And just like you can have URLs for web pages like that, you can also have URLs for data. And so this is just a quick example of that from the Twitter API. This is a URL for the getting the tweets of a particular user from the API. And so you see in red there the user ID that is being used to fetch or it's designating which tweets to get, so which user. This happens to be Barack Obama's user ID. So when you resolve this URL, if you have the keys to do it, and maybe we'll talk about that a little bit later, but you basically need to have keys from Twitter to be able to get this data and from the API. But once you do, you get back data. That data comes back in what's called a JSON format, so JavaScript object notation. It's basically a structured metadata format where you can look at the data for a tweet in a very sort of programmatic way. Now, I mentioned API clips in the title of my talk, and this is a term that actually Axel Bruns came up with. I think this was in 2019. And so he wrote a paper after the API clips, social media platforms and their fight against critical scholarly research. And so his paper is largely about the response to the Cambridge Analytica scandal. And basically Bruns points out that after the Cambridge Analytica scandal, a lot of social media platforms decided to restrict access to their APIs in various ways. Some of them, removed parts of their APIs. Some removed all of their APIs. Some, controlled how much you could access those APIs. And so he points out in this paper that there are kind of like 4 different ways. I don't know if it applies, if he was recalling the 4 horsemen of the apocalypse, but he recommends 4 different ways of sort of dealing with the situation. Those were largely to either stop doing this kind of research, right? To walk away from doing social media research, to try to change the actions of these companies, right? Largely through lobbying and political work, right? Which I think is happening at the moment. You can also work with the APIs that are left, sort of like accommodate these corporations. And then the 4th one was to basically break the rules and to sort of work outside of the APIs and sort of go against the terms of service by scraping. And I think we've seen some cases about this, recently, thinking of Christian Sandvig from University of Michigan, his case that I think was in front of the Supreme Court around scraping and the rights of researchers to scrape data. So all of these approaches are appropriate, and they're not like, they can be mixed and matched, right? Like it's not like you have to pick one, but these are some of the avenues that are open to us as researchers. Just quickly, if you're not familiar with the Cambridge Analytica scandal, so this happened in 2018, yeah, a whistleblower leaked that there was a researcher at University of Cambridge in England who also was working as a contractor with this company called Cambridge Analytica, who do lots of political data analytics work, right? That they had basically, this researcher, as a researcher, had collected 50 million Facebook profiles and given that data to Cambridge Analytica. And Bruns points this out in his paper that a big deal was made out of this case, and rightly so, because it was not a good thing what happened. But he points out that this is actually very emblematic of things that were going on all the time, right, with social media platforms. Shoshana Zuboff, in her recent book, Age of Surveillance Capitalism, she highlights how pervasive this economic model is, right? Like where these platforms are taking our data and then using it to do predictive modeling. Anyway, so this is just to provide that little bit of context to why Twitter and these other social media platforms have decided to change their API access. Fast forward a little bit to earlier this year from Cambridge Analytica. In January of this year, Twitter announced that they have this new academic research product track, which is a way for researchers to basically apply and get access to their API. And it's not their version 1 API. So Trent mentioned there was a version 1 API and a version 2 API. The version 2, they're both currently available, but version 2 API has some things that I'm going to talk about in a moment here. It has some benefits, but some negative aspects to it that you probably need to be aware of if you're going to use it. This academic product track, it kind of it positions Twitter as a sort of an arbiter of like what academic research is, which is kind of strange when you think about it. They are basically, when you apply, and it's pretty simple, you can apply in like 10 minutes. It's a very simple form. And you can, they basically are looking for evidence that you're an employee, a research-focused employee at an academic institution. So like grad student or faculty member, or somebody that's doing research. They do ask what your research objective is. So, and I think the more specific you are, the more likely I've heard you are to get granted access. This is basically your research question, right? Can be difficult though if you're doing multiple projects. Which one do you talk about? Do you talk about them in the aggregate? Can be a little bit tricky. And the other thing is that they are looking for non-commercial uses. So that also can be tricky. If you're working with a commercial entity, knowing when the boundaries are being crossed or not could be difficult depending on what you're doing. So the good parts of this academic research product track and the version 2 API, which I'm kind of lumping together here because of the audience, we're largely researchers, right? There are no more contests for data. So Twitter and other social media platforms were doing this for some time, where they were basically asking for people to submit their research ideas, and then they would cherry pick a very few number of them to work with. And so this is much more comprehensive access. It's designed for lots of researchers to get access to it, which is a good thing. You can now search the full archive of tweets. So unless you're lucky enough to have, like Trent mentioned, the fire hose, which is the full access to data, which some institutions do have that, but it's it's pretty rare, I would say. Previously with the version 1 API, you could only look for the last 7 days of tweets through the search API, which is pretty problematic if you're looking for historical events that have happened. And now with the version 2 API, and when you have been blessed as an academic, you can get access to the full archive. There are no more stream volume throttling. So when you are collecting from the live stream of tweets for a very high volume event, like for example, like a political debate or a sporting event or something like that, where there were a large number of tweets, previously you would get throttled. You'd basically get a message saying that a certain number of tweets have been dropped. And that appears to no longer be the case with the new version 2 streaming API. You can also change your rules for how you're collecting from the streaming API on the fly as you're collecting, which is kind of nice. So you don't have to stop the streaming and then start it again with different set of rules. You can basically change it as you're going. You can also collect conversation threads. So this is really important if you're doing any kind of analysis of conversations on Twitter. Being able to get a thread was previously kind of difficult with a version 1 API, and now it's quite easy with a version 2 API. And you also get additional metadata now. So people's, places, organizations, I think they call these annotations, but they're basically structured metadata for entities that have been recognized. Take this with a grain of salt because they have their own sort of machine learning processes for identifying these entities. but it could be quite useful depending on what you're doing. So the bad things, the premium product offerings, if you were using them, are going away. So those ways that you could pay for access to data are going to be phased out, I believe, this year. At least if you believe what they've said. Twitter is a gatekeeper for what is research, kind of problematic, right? Especially if your research is looking critically, as Axel Bruns points out in his paper, at the platform itself. It's possible that maybe, they might not grant access depending on what you're looking at. A big one, and maybe hopefully there's time for me to talk about this real quickly, but it used to be that when you got the data for a tweet, there was one representation of that tweet as data. And it's changed slightly over time as they added features and whatnot, but you didn't have to ask, no matter how you asked for the tweet, you would get sort of the same basic shape of data back. And that's no longer the case with the version 2 API. How you ask for the data is very much shapes like the type of data that you get back. The quotas are much lower. So, and it's slightly better if you're blessed as an academic researcher, but so the quotas are basically how much you can get out of the API for a certain period of time. And just as a quick visualization of that, the blue line here is the version 1 API and the red line is the version 2 API. And this is just visualizing a month. So how much data you could collect in a month. And this is from the search API. So previously you could collect from the search API about 140 million tweets per month. And with the version 2 API, the search API, you can only get, you get basically capped at 10 million. So it's quite different. The same is true for this filter stream API. So that's getting the live tweets from Twitter that you could get over, I have 350 million tweets there in a month, whereas now you're capped at 10 million. So this is a big change to how much data you can collect in a month. And this is for the academic access. I mentioned the canonical representation is going away, but so just real quickly, just to give you a sense of this, when you request data for a tweet, you have to indicate now what expansions you're interested in getting. And so these are basically like ways of saying that you're interested in particular pieces of data. So the attachments or users, if there are polls in the Twitter data, what tweets are referenced in the tweet, so if it's a reply to another tweet. And for each of those expansions, there are a set of fields that you have to also indicate that you're interested in. And so there are all these different fields and expansions, and it's very complicated. And so this is a big headache for people that are used to getting Twitter data from the API and sort of processing it in a particular way, because now tweets can take so many different shapes depending on how you ask for it. Maybe just real quickly before I finish here, I'll just show you a quick demo of a tool that we call Twark. So I mentioned that I work on this project called Documenting and Now, which is a social media archiving project that's been going for 6 years, 3 of which have been here at the University of Maryland. And one of the tools that we've developed is this tool called Twark, which is a command line tool. It's actually written in Python, so that's what the snake is doing there. And it's really oriented around saving data. So that's what the disk is doing there too. So it's a tool for collecting data from the Twitter API. It runs at the command line. So, oh, I apologize, you're seeing my email here, but yeah, if you haven't opened a command line tool before, all operating systems have something called a terminal or command line, and this tool basically works that way. Once you've got it installed, you can write in your terminal Twark2, so that's the tool, and then it takes a set of subcommands. Actually, there's a whole bunch of different subcommands that it can take, which you can see listed here when you do the help command, but yeah, one of them is search. And so that interacts with the search API that I mentioned, that Trent was talking about too. And you can give it a query. It could be a simple query like this, right? Like where I'm just looking for COVID-19. And what it will do is connect to the API and then just output it to the screen, which is probably not terribly useful other than to show you that it's working. Normally what is done is you will write it to a file, right? And so you can run this command, and what it does is this one, because it's using the search API, it's working backwards in time from the current point in time backwards, looking for tweets that mention COVID-19, and then it saves them to this file covid19.jsonl. And JSONL is just line-oriented JSON. That's the format that it comes back from the API in. And then when you're done, you can, if you want, you can do a bunch of things with this data, but one thing that you can do is, convert it to CSV. This can be useful for looking at it in a Google Sheet or, Excel or, lots of data frames. So like in R or Python, like if you want to load a data frame from CSV and analyze it, it's super handy for that.
That's pretty cool.
I could.
I need to make sure we're not all starting typing with the command lines, but reserve a little bit of time for questions at the end.
Yeah. I'm actually done here, so this is the end. So that's good timing, I guess. Oh, I will mention though, just before I stop, that if you want to learn more about the tools, there's this URL here, docnow.io, that talks about the project. It's actually a project that started after the killing of Michael Brown in Ferguson, Missouri in 2014. So a lot of these tools were developed around collecting activist work that was going on. And so, yeah, let me stop sharing here.
Thank you very much, Ed. And you might want to look at the Q&A. I think you can share here with the audience the link to your GitHub slides. I already saw a couple of people asking for that. Having both of you now back on the podium, let me first thank you for two wonderful talks and start or make sure that we touch on one of the questions posted, which was sort of related to which vendors are you using. Now, the API is not a vendor, right? We learned that now, but I guess there can be an advantage or some rationale for using vendors here and there. And I was wondering, Trent, if you still do that or if you entirely switched on your sort of own sampling methods.
Yeah, that's a really good question. So to evaluate our methods, we didn't have Firehose access ourselves. And we could do, since we're using the Twitter version 1.0, we could have actually gathered censuses from the actual Twitter search API ourselves, but this takes an enormous amount of queries. And because we were covering many geographic areas with large volumes of tweets, we didn't spend our queries that way. So we ended up going with the vendor to provide Firehose access to generate these populations, benchmark quantities that we use to evaluate the sampling methods. And we used actually Meltwater to do this, but there are others, the other vendors like Brandwatch, which recently purchased Crimson Hexagon. So if you're familiar with Crimson Hexagon, it was purchased by Brandwatch, and they actually have an interface that you can buy that gives you full throttle access to Twitter Firehose, but also to Reddit and other sort of social media platforms. But it's about $60,000 a year, even with academic discounts. So it's not cheap. So we went with Meltwater for this project because it was much more cost effective to generate these estimates. But yes, there is a place for it. Now, one of the things that the literature would tell you is that even if I were to do a Twitter census, which we ended up doing to test this anyway, and you compare it to the Firehose, you will get different answers potentially, because the Firehose vendors, by regulation of Twitter, have to remove tweets that go public or that go private, and they're constantly sort of curating that Firehose sort of output. So there are some differences that are beyond the control of the researcher, but that's sort of what we have today.
Excellent. Ed, anything to add to that on the vendor side?
No, I mean, that's interesting to hear about those different vendors. And I think, I think of Twitter as a vendor though, right? Like, even though they're vending their own data, like they,
Fair enough. Yeah.
yeah, they're a vendor.
Yeah.
Yeah.
Ed, you mentioned, what did you call this? All those expansions. And I guess, Trent, what you've been using, the geographic location, is one of those expansions. So I was wondering, Trent, could you see your methodology being sort of expanded to use some of these other expansions that Ed introduced? And I was also wondering, how complete is that? I mean, the metadata probably have missing data themselves, and not all are geotagged. So maybe you can.
Yeah. So we didn't use geotagging at all. So our vendor, in order to identify sort of location and to be able to make apples to apples comparisons between our samples and the vendor benchmarks, couldn't use geotagging information from Twitter. It was part of their terms of use. So we actually based all of our locations on the user metadata with the city name itself. So, or did you live in Atlanta, or did you live in Chicago? And we actually used our pilot data to amass all the ways people could misspell Atlanta, and we used that in our AI to sort of figure out the locations. But about 60 to 75% of people actually have a user location, and that can change over time. And we didn't include retweets because retweets inherit the user location of the person who originally tweeted. And because we were looking for local inference, we excluded retweets to avoid that problem. One thing to mention is that the version 2 API does not have a geolocation tag a priori as part of the payload. You actually have to filter after you get the tweets. Version 1.0, you can filter at the time of tweet acquisition using a geo filter. So that's what we did to make it more efficient.
That's interesting. Thank you, Trent. And one last question that we have here in the chat is on sort of ethical considerations. You mentioned the use of social media data for research purposes, and then a secondary use to make some additional money, or whatever the motivation might have been. Are there any considerations that you would like to give people on the way as they think about using Twitter data for their research? I mean, here too, we know from some studies that not everybody who's using Twitter is sort of having that in mind, that this is really public and can be used for research, for example.
Yeah, absolutely, Frauke. And that I think that's the most important thing to know, is that not all users fully understand the publicness of their tweets, right? And yeah, Nicholas Porphyris has a really nice study about that, like looking at user expectations around how Twitter is used. I guess like it kind of depends, right? Like as with ethics, questions always are so the context matters so much, right? And when you're doing statistical work, like Trent was just describing, where you're looking at a population and characteristics of a population, the ethical concerns there compared to like when you're maybe doing a qualitative assessment of someone's timeline or a conversation, potentially even quoting, tweets and putting them into research materials, they're just so different, right? And I think that a lot of the ethical concerns come into play when the voice of the people that are creating the tweets becomes the thing that's being studied, and so consent becomes very important, I think, when publishing research about things that people have put online, and also it's also important too when you're sharing data sets. I think after the fact, the way that you choose to share the data is you definitely need to think about the ethics of what you're doing when that happens. But that'll be like a whole
this is the segue into the next talk starting.
Yeah, maybe.
Yeah. Thank you, Ed. That's very thoughtful, and I love your distinction on sort of thinking about the context and the usage of the data, and not sort of a general assessment. So this is super helpful. We are at time. Thank you both, Trent and Ed, and thanks to all the participants. Again, we will be sharing the material for the recorded videos, as well as the slides on the SOTA website. And if you like to receive notification about upcoming events or are interested in the jobs we have, email us at socialdata.science@umd.edu. Again, thank you all, and have a good end of the semester. Bye-bye.